So today we're going to discuss around the societal impacts and regulations in terms of the advances of 6G, really thinking through the kind of huge ambition that we've heard about, some of the fabulous use cases, but also what that then means in terms of how we use that system and how we balance those kind of security interests as well as privacy issues for the end users. I think the other theme that we've really picked up as well from the end user's perspective is thinking through things like standardization, inclusivity, data security and privacy. So through this panel, we will seek to discuss those kind of challenges related to standardization, spectrum and regulatory frameworks. So I am going to be cheeky and I am going to ask the panel to introduce themselves rather than me kind of botching and giving you guys that chance to kind of introduce your perspective. And alongside that, if you can maybe just highlight what excites or worries you the most around the kind of advancing or evolution towards 6G. So maybe we'll go in order, and I'll start with yourself, Anna.
Hello, everyone. I'm Anna Maria Mandalari, Assistant Professor at University College London, where I lead the SafeNet IoT laboratory, where we have hundreds of Internet of Things devices, and we measure privacy and security, and what kind of issues of privacy and security we can have for the users. I'm also honorary research fellow at Imperial College and a visiting professor in National University of Yokohama, and in the board of the IoT Security Foundation. What excited me more about 6G is, of course, the possibility of having a world that is hyper-connected. So billions of Internet of Things devices finally can be connected between each other without any boundaries of locations, for example, of latency. But from the other side, of course, there are some risks, particularly privacy and security risk, particularly for the end users. And we want to be sure that the user will have back the control about the privacy and security, and this is not an easy task.
Thank you. Anas?
Right. I'm Anas Arawi. I'm a Principal Technology Advisor with Ofcom. I sit on the telecom side. My role in Ofcom is to bring the technology element to policy making. Okay. Now, you've asked about what excites me about the next generation. I think if we just break it from where are we today and where do you want to be in 5 years or beyond, connectivity in the UK is progressing. My colleague Christina Data yesterday, she mentioned full fiber now 70% in the UK. If the planned network deployment are realized, we will reach 96% by 2027. Implicitly, that will drive connectivity indoors. Okay. When it comes to 4G, we have 95% landmass coverage. 5G is slightly lagging behind, not slightly, lagging behind. Satellite to broadband is growing. Direct-to-device is emerging. We published a consultation on D2D a few days ago. And I should also mention, we published a consultation on the Telecom Access Review to basically stabilize the industry to drive and continue the investment to hit the full fiber targets. So you have these multiple technologies, and every technology addresses a certain consumer need or specific use case. They have sweet spots, and I think now there is a broader consensus that there's no silver bullet. You have all these technologies will have to complement each other to connect the unconnected, for example. Okay, and also there's an element of resilience when you have multiple technologies. For example, with D2D or direct-to-device, it provides that fallback option when you are in the hardest to reach areas. So that's my aspiration, let's say, subject to commercials, of course. Okay, if it's commercially viable or not, that's a question will answer itself with time. Hopefully, once we've solved the consumer problem, I hope then the industry verticals, hopefully then will take off, and that will drive new use cases, new growth opportunities and innovation. That's the aspiration, again, subject to commercials. What worries me that the aspiration don't get materialized, so that's me.
Great, thank you. Matthew?
Thank you, good afternoon, ladies and gentlemen. So I'm Matthew Baker, I'm a Bell Labs Fellow at Nokia, and I lead one of Nokia's radio standardization teams. I've been involved in 3GPP, working on 3GPP standards for just over 25 years now. So I started with 3G, I've done 3G, 4G, 5G, and just on the cusp of starting 6G. So 2 weeks ago we had our launch workshop of 6G in 3GPP out in Korea. Very exciting event. There were 800 people there presenting their visions for 6G, and I think that leads me directly onto what excites me about 6G. It's a once-in-a-decade opportunity to do something different. Once in a decade, when we start a new generation, you get an opportunity on the device side to refresh the chipsets, to start again with a fresh chipset design from scratch. And that's where you get the opportunity to bring in new technologies from day one. So if you look at 5G, we started working on NTN, about non-terrestrial networks, about halfway through 5G. And it hasn't yet made it into any of the devices because it requires fundamental hardware changes to the device. So this once-in-a-decade new generation is a golden opportunity to bring in the hardware impacting features. So we can bring in non-terrestrial network connectivity from day one. We can bring in AI from day one. So we're working on AI now in 5G Advanced. But 6G will be the first opportunity for an AI native system from day one, where AI is not an add-on, but it's something that's built into the network that gives the possibility to dynamically evolve the network in real time, to take away much of the complexity from the network operators, to optimize the network. Hopefully to save some energy. We hope it saves more energy than it uses. We have to see how that one works out. But all of those aspects we can design in from the beginning. And in terms of the societal impact, of course we hope it'll improve everybody's lives with better connectivity. One of the ways that we expect that to happen in the area of sustainability, 5G, if you look at the energy per bit, is by far the most efficient mobile system yet. But we need to do a lot better with 6G. We need to make it even more energy efficient. We want to see absolute reductions in energy consumption in the network. We hope that AI may play some role in helping us with that, but also, as we heard earlier, it's just about really figuring out how you can optimize every single aspect, both on the network side and the device side. But mobile connectivity also brings benefits in terms of what it enables people to do, that they can meet without traveling. That's what we call the handprint of sustainability, that we're not just having a carbon footprint, but we're helping other people to reduce their carbon impact. Very exciting if we can achieve that. What worries me, and it's a very good thing I'm sitting next to my friend Anas, because I think my biggest worry is that we won't have enough spectrum to be able to deliver that.
And it's a good point to pass on to Dominic.
Afternoon. So my name is Dominic O'Brien. I'm a professor in engineering science at the University of Oxford. I'm here as the director of the HASC Hub. So with a hub in all spectrum connectivity, that's one of the 3 future telecoms hubs graciously funded by our friend Derek, who's sitting at the end of the panel there. In terms of what excites me most about 6G, I think it's almost what Matthew said, but with a slightly different slant. It's the rewiring of our infrastructure. He talks about the once-in-a-decade opportunity. Now, of course, the fibres are replacing copper that might have been a century old. So we're not talking a decadal opportunity for the optic side of the 6G story. It's probably once for the next 50 years. For many of the installations of things. So I think thinking more broadly than just base stations and wireless access, but thinking of the way that this infrastructure is being rewired, there are really exciting possibilities, not even around, heretically he says, wireless access, but possibly even wired access to things as well, that this is now enabling. We should think holistically about this. That's what excites me. I have to say what worries me is some of the stuff that our colleague brought up in the last panel, is that we increasingly have this disconnection between the control of the world we live in and the actuation of that control. The software sits between. you can turn on a light, which is a software light switch now. So I think we need to be very careful about the complexity of what we're creating and the risks that brings. It really does need to be designed very carefully to make sure that either by human intervention, which is usually the problem, to be honest, that this thing is actually going to be the reliable, resilient infrastructure we want.
Okay, Alexander?
Yes, good afternoon. I am the alien of this group because I'm a biologist by training. Nevertheless, I have investigated biological effects of magnetic and electromagnetic fields for 35 years now, starting with 50 hertz and ending so far with 5G, 27 and 40 gigahertz. I have been member of the German Radiation Protection Board and as the chair of the non-ionizing radiation sector. I have also been expert panel member of WHO about mechanisms of biological effects of electromagnetic fields. And I'm excited about the possibility to convince the general public that electromagnetic fields in the radio frequency range is not dangerous, but I'm afraid that I will not succeed. The discussion about the potential dangers of 5G in Germany, but also in other countries, worries me a lot because it's very difficult to bring science to the general public. I was also kind of masochistic because I was trying to convince people in panels, general public, when there was a base station erected. I was trying to convince them about the science, that there is no effect so far, but it really doesn't work. And that makes me very skeptical about the acceptance of science by the general public.
Okay, and I think we're going to cover off each of those, both excitements and concerns, as we move through the questions. So thank you very much for those kind of brief introductions. So if we kind of pick up in one of the other topics that's came through some of the panels, so the kind of this morning and this afternoon around international collaboration and kind of unification towards ideal standards and ensuring that those aren't disjointed. So how can we ensure that we have a more unified and globally accepted approach towards standardization for 6G deployment? Who wants to take that one first?
Yeah, I'm happy to take that. I think the first thing to say is that fragmentation will not benefit society. It will not benefit anybody. We need to have a single global standard, and I think actually we're very well on the way to achieving that. So over the last 3, 4, 5 years, there's been a lot of pre-standards work, uniting in various ways the different research projects that have been going on in different regions of the world, which may on the surface look as if they're independent research projects, whether it's in the Americas, in China, in Europe. But the reality is that there are a lot of global contributors who help to bring those discussions together. And by the time we started held the workshop 2 weeks ago in 3GPP, which of course itself is a global collaboration, global partnership project, there's a pretty good alignment between across the industry, including all the sectors of industry globally, on the general directions in which 3GPP should be heading for 6G. So I think so far so good.
Anyone else want to jump in on that one?
I think it's not easy to have like harmonized standard on 6G, but we are in good direction in Europe, for example. And a good example like of standardization in the past that's really for which we really succeed are like standardization about privacy, for example, regulations about privacy. These things was complicated at first because of cultural problems. So let's say, for example, in some countries, privacy is like interpreted differently from some other countries, but because in the end manufacturers, 6G manufacture, for example, devices that use 6G as connectivity or other connectivity standards, needs in to sell in different countries with different regulations, standard plays a real game on this, and it was easier to have a global standard thanks to this.
Okay. So maybe kind of focusing down a bit more than on the regulations. So what are those kind of major hurdles that we face in terms of regulations, and how can we kind of engage that ecosystem early enough to start kind of addressing those as we move forward?
So I wouldn't call it a hurdle.
Okay.
There's a process. We follow the process. We improve it over time. So regulations don't happen in vacuum. Okay, so you have to engage with your stakeholders. We engage with the industry, with colleagues here sitting on the panel, colleagues, I recognize them in the room. So you have to bring everyone on board. Okay, so we run call for input, CFIs, consultations. We have consultations at the moment running relevant to my colleague Matthew on spectrum regulations. So it's a very much a collaborative effort, just like standardization, right? So there is, I mean, if we also touch on the earlier question about standardization, you need a standardization, you need harmonization for regulations, so you can have economies of scale. How can you make the technology cheap enough for consumers to afford it, right? And you need also interoperability as well to have resilience in the supply chain. In Ofcom, we also keep an eye on the tech, because it's, so if you look into our, let's say, duties, we have duties under the Comms Act to promote innovation and competition, but then we have also other obligations under the Wireless Telegraphy Act, where we have to ensure the spectrum is being used efficiently. So we have all these, let's say, different, well, you have duties to further interest of the consumer in innovation and new technologies, promote growth, ensure spectrum utilization is as efficient as possible. And then we have also other, let's say, requirements on service providers in the UK. So if you are a public electronic service provider in the UK, there are general conditions or requirements on the providers they have to comply with. First, to basically make the services as widely available as possible, protect consumers, but also respect confidentiality between, let's say, the providers themselves, because they need peering. So, do I call it hurdle? It's a process, right? Now, I think what you may call roughly a hurdle, these competing duties, they need to be proportionate. And it is a delicate, you have to find the right balance, right? So when it comes to spectrum regulations, you need to harmonize also within your neighbors. You need to be a good spectrum neighbor, but there's also a broader element to it. There are regions within the ITU they have to harmonize, and probably my colleague, he's more involved in this than myself, because I sit in the telecom or the NNC group rather than the spectrum group. So yeah, I think that is one element that you probably can class as hurdle, but for me it's a process and we have to go through it. And then there's security and resilience, has been touched on earlier, okay, and that is a cost. So we have published our new resilience guidance on services and networks late 23. And I advise everyone who is interested in security and resilience, please go and read what kind of threats networks face, from external physical threats, natural disasters, climate, human errors, technology, cyber, etc. So one of the pieces of work that we've been working on is, for example, power resilience, local outages. How do you handle, are we okay? I think.
Talking about security.
Power outage. Do you have a UPS?
The laptop needed to have some more coffee at the break.
Yes.
Please continue.
So for example, when we looked into the battery power backup to provide a fallback option in areas where you have local outages, the paper is published. I advise you to go and read it. The cost is not commercially viable.
Yep.
So again, you have to go back to the drawing board and say, all right, let's see again what could work and promote growth, protect consumers, and also, let's say, deliver on the duties we have.
Okay.
Hope that makes sense.
So maybe we can just dive a bit deeper into the spectrum question then, because I know a few of you raised that in terms of concerns as we were moving forward. So considering the constraints around spectrum, is spectrum sharing the way forward, and is that how we're going to proceed? We'll pass to Matthew first, perhaps.
Yeah, I mean, spectrum sharing, there are different flavors of spectrum sharing. So there are some areas of spectrum, or areas both in spectrum and in geography, where there are existing incumbents with whom any new technology would have to share in order to open up that spectrum. So a good example would be in the US, the 7.1 to 8.4 gigahertz is a prime band for 6G, currently with a number of different incumbents, some military-related, radar, some fixed links, some satellite services. And because they're incumbents, they're already there, they have a certain priority, and we have to work around them. Now, it may be possible from a regulatory perspective to do a bit of repacking of those existing links to try and free up. It's always better when you have contiguous spectrum. That's much more efficient to utilize for mobile. But one way or another, any 6G system in that band will end up having to share with those incumbents. And the kind of sharing that would be relevant there would be relatively static. I mean, varying levels of dynamicity. You might have a database, you might have some kind of sharing controller that you can interrogate at various update rates, might even be down to a few milliseconds in the most extreme case. But what it's not is simultaneous operation, sharing the spectrum simultaneously in time and frequency. That becomes very difficult. You then have to look at the interference and the coexistent aspects both ways, from the incumbent services to the new 6G system and vice versa. Either way, there will be severe degradation. You're much better off if you can have clean spectrum and share in a time domain manner. So that leads us then to the sort of elephant in the room, which is the European situation, where the prime spectrum for 6G, because the above 7250 megahertz is pretty much out of the question. We're basically left with the spectrum between 6.4 and 7.1, 7.2, that sort of range. And there you hear a lot of discussions about is it possible to share with Wi-Fi? Can we have some kind of sharing between 6G and Wi-Fi? And I think there it's very important to listen to the mobile network operators, who in the end will be deploying the systems. The number one feedback that we get from our customers, the network operators, is that, of course, the cost of significantly densifying the network is enormous. It's very challenging. It may even be impossible in terms of identifying sites, getting power supplies to the sites, and rolling out the network is not feasible in terms of capex in order to roll out 6G. So the number one requirement from operators is to be able to deploy on the upper 6 gigahertz band using the existing mid-band site grid. So the existing primary spectrum for 5G is the 3.5 gigahertz, which they've rolled out the network for coverage at that frequency in metropolitan areas at least. The challenge then for 6G is, can we achieve the same coverage with the same sites even though we're operating 3 gigahertz higher? Now, that may sound like an impossible challenge. We actually have a very nice demo of that, which it's currently in just outside Helsinki. We've got a test setup where we actually have two antennas, identical size, but one is operating at 7 gigahertz, one's operating at 3.5. You have 4 times the number of antenna elements. And we're getting pretty much the same coverage with the 7 gigahertz as we do with 3.5. That's the challenge. The problem is, as soon as you put Wi-Fi devices out there, you lose that completely, and you lose the possibility to get that kind of coverage.
Okay, thank you. Dominic, you want to come on?
Yeah, I suppose I'd take a slightly broader view than the nearer term to say it must be the case that with digital twins, with AI, one can control these systems dynamically in a way that actually is just emerging, specifically if it's built in as a native function, not necessarily into 6G as you're talking about it, as these networks evolve. And so being able to sense what's going on, that seems to be improving. So, for instance, the UK's building, Demetra is leading a project building a monitoring network, which at least will give good data, which will give you some idea of the way these techniques could perform, as it were. And I guess there's a regulatory side as well, that actually, if there's a way of automatically allocating spectrum on some sort of dynamic basis, it seems to me there'll be some structural kind of allocations, which are more the things you're talking about, that actually you need to know the rules, and they need to be clear from word one. And then there'll be surely areas where dynamically you can do this on the millisecond level, where actually you are responding much more to the local environment. And the technology that seems to be emerging, at least though the modelling and some of the academic work seems to say that seems to be feasible.
Anis, do you want to come in for the regular
Yeah,
perspective?
absolutely. So, so again, I will refer back to the Wireless Telegraphy Act. So we have two tools to grant access to spectrum, either license or license exempt. So where we think auctions are the right tool is where there are high demands. So if there is high demand and you want assured reliability, and there are no degrees of freedom. You know, basically, there are no degrees of freedom to share a spectrum on this site, because eventually then you will collapse into interference. Then you go through the route of auction. And we have the millimeter wave consultation. It's been delayed because of the merger. But then, on the other hand, if you have degrees of freedom, then sharing is a valid option. And we have increasing demands. And diverse demands is from satellite, from Wi-Fi, from cellular, from other, let's say, Earth observation. There are multiple other players, they demand that spectrum. So when you have this, well, you have scarcity in the spectrum and you have diverse demands, what do? So you have to look into, okay, if there are degrees of freedom, and my colleague Matthew mentioned the upper 6 gigahertz, there is an ongoing consultation, and there are two proposals, and you are very welcome, and I'm sure Nokia will submit.
We will.
So you have the, if my memory doesn't fail me, so there's the hybrid sharing element to this proposal. You have half of the band is dedicated to Wi-Fi. The upper one is valid for sharing between Wi-Fi and cellular. And there's another proposal which is based on indoor and outdoor. So it's in a consultation. It's ongoing. We'll have to wait for all the responses, take that on board, analyze the responses, and then basically come up with a solution going forward.
So I don't think any of us want you to prejudge where the consultation is going.
And there are also what we call shared access licenses. So there's the 3.8, 4.2. I mean, the key thing from having these different ways of regulating spectrum, yes, we have a duty to drive the efficiency of spectrum, but also we need to open the door for new services and applications and networks, so private networks, neutral host. So we can't put emphasis on it just.
And I think you're reading my mind about where we're headed next. So
yeah, I do that. Yeah.
So how can we ensure that we balance that then? So how opening up spectrum in terms of really fostering innovation, getting some more kind of disruptive innovation happening, versus ensuring that reliability? I don't know, Matthew, maybe if you want to kind of...
Yeah, I mean, I think Anas has made a very nice segue there to the 3.8 to 4.2, and Ofcom has there been quite a trailblazer in terms of opening up local access licenses, enabling small enterprises, people who want to operate maybe a private network on a particular site can apply for either a low power or a medium power license with particular power limits associated. I think that's a beautiful way of using that band of spectrum, making spectrum available for enterprise in that way. It would be great to see more use being made of it, I think.
I hope so too.
Great. So just the kind of last question maybe on regulations before we pivot a bit more into the societal impacts. So what potential new regulatory models do you think could be explored to keep pace and really encourage that development of 6G technologies? I don't know, Dominic, if you maybe want to kick us off.
I suppose I made some of the points a bit earlier given that the technology would allow you, if the conditions were right, more dynamic allocation of spectrum, I guess the regulation has to follow that to make it effective. From an academic perspective, what can we do? We can provide some data, some modelling, some measurements to say, well, this is the condition that you're in. We can develop techniques that says, well, if you're in these conditions, if you moved from A to B or shared in a particular way, you would get this performance. So we can set out a series of options and things, but whether those, it's a bit like standardization. The options are there. Whether those are taken forward are to do with the economics, to do with the practicalities, and ultimately to do with the regulation. So I guess it's the regulation matching the potential, if you like.
Yeah,
I will add a brief point. So there is a set of projects run by DCIT on spectrum sandboxes, and I'm sure some colleagues in this room involved in this project. So we do, again, engage with the stakeholders to encourage new innovative ways of thinking and demonstrating new ways of utilizing spectrum. And what my friend Matthew mentioned, AI will be native, and also colleagues earlier mentioned the software element, the softwareization of the network. So you would like to think there will be intelligence to basically all these enabling elements will come together to allow you to do more spectrum sharing. There are also other projects we in Ofcom involved in, like Sonic Labs. I was involved in this project early days. So there are various initiatives where we try actually engage with colleagues from academia, from industry to bring in new innovative ways.
I'd just like to add that I think there's also a forward-looking element to this, and we've had particular conversations, for instance, about what happens if optical spectrum gets widespread use. What do you do about regulation for that? So it's not necessarily regulation about what's being used now. It seems to me it's a continuous picture that actually, and it's interesting to think forward about why would you regulate, what would you regulate, how would you regulate.
That's a really good point. So just so Alexander doesn't feel like an alien, as he mentioned at the beginning, I think we're really interested in that kind of societal consideration. And as you mentioned, around about the kind of implementation and deployment of 5G, there was a lot of kind of concerns raised by perhaps people that didn't have the same kind of benefit of the information that some of us do. So perhaps maybe we just expand upon what perhaps current research says about the potential effects of higher frequency radiation and potential 6G, and how we could kind of build public trust.
That's a complicated question. I mean, what we have done for many years now is to study potential effects of exposure of animals and cells, and also some studies were done in humans, and look for the effects. And in 2010, WHO said the only mechanism we know how electromagnetic fields or at high frequency work is by heating up tissue. And this is definitely prevented by the standards, by the upper exposure limits. So there is no other mechanism. Nevertheless, we have done, and others have done many experiments to look for potential side effects or biological health effects. For example, we have done in Bremen the world's largest study in mice over 4 generations, exposing them at the exposure limits and above, and we didn't see any bad health effects. So all the mice were doing well. There was no effect on body weight or litter size or whatnot, so reproduction was also working. There was no brain tumor incidences increase and so on. Recently, we have finished a study in human skin cells at 27 and 40.5 gigahertz, again at the legal exposure limit and 10 times above that. And we haven't found any evidence for DNA damage or methylation of DNA molecules. That is very important because the skin is, of course, the structure where these higher frequencies are absorbed. And so from that point of view, and this study is going to be published soon. I had hoped to tell you this is being accepted, but anyways, this will be published, and we hope that the public, the general public, will ultimately be convinced by scientific data, hard scientific data. But that is a challenge. We have to bring this scientific data to the public, and in this regard it is also important for us scientists not to be financed directly by the industry, because then the general public say, yeah, you are corrupt, you know. And yeah, that's the standard argument, and therefore it was important for me always to be funded by the government, although the industry gave the money. But it was, of course, a very important thing. So, but I think the 5G hysteria has gone down significantly, and everyone is using mobile phones with 5G, and everyone will be using 6G in the future. So my hope is, and hope dies last, that also the general public will be convinced in the end that there is no danger.
I think that touches on a key issue though around public trust. I think not just on the health side, but obviously around data privacy and data security, especially, well, having worked across a number of technology areas, as soon as AI gets mentioned, there is a lot of hysteria that gets driven. A lot of people really doubt the kind of safety and ethical use of AI. So I wonder, maybe Anna, if you can lead us off just thinking through how we can use regulatory frameworks, just thinking how we can ensure individuals retain that control over their own data.
Yeah, super important question. So basically, I will answer this question with this question with another question, like how many of you thinks that at the moment the regulations are protecting users? Like, are you aware of regulations, privacy regulations that at the moment is protecting users? Like an example is European GDPR or UK GDPR. How many of you thinks that this is actually working? Okay. Do you think that we have any framework for enforcing GDPR nowadays, or any other regulations on connected devices? Can you mention some?
For example,
yeah.
As far as I'm aware, you can be legally prosecuted for mishandling customer information.
Yeah, but at the moment, the only tool that the user has for understanding that the privacy was violated is to read through these 40 pages of terms and conditions of privacy policy. This is the only way, and the only way that basically the user has for regulation. And then from the other side, so this is from the user point of view, and from the regulator point of view, how many tools, for example, Ofcom or the Information Commission Officer framework have available to understand enforcement of these regulations? Can you list some?
Can I list?
So
Right.
this is the main thing, right? There is a big gap.
So we mentioned collaboration earlier.
Yeah.
Okay. Have you come across the DRCF, the Digital Regulation Cooperation Forum?
Yeah.
So this is basically, you have the FCA, you have the ICO, the Information Commissioner's Office, you have the CMA, and you have Ofcom. What you regard as privacy and electronic communications regulations, or PECR, alongside the Data Protection Act and UK GDPR, that sits with the ICO. That's not Ofcom.
Yeah,
okay?
yeah, exactly.
Now, under the DRCF, because we have this collaborative approach to regulating digital technologies, There is a joint statement from Ofcom and the ICO. Remember, Ofcom now, under the Online Safety Act, we have obligations to protect users, UK citizens, from illegal and harmful online content. I would advise you to read the 3-year plan for Ofcom that will give you nice pointers to where to read and seek answers. And I'm happy to speak to you offline and connect you with colleagues within Ofcom. So currently the priority is for child sexual abuse.
Yeah.
The priority may change over time, could be banks, I don't know, I can't speculate, but you have to go through, again, that process that I mentioned earlier, so it doesn't happen in vacuum.
Yeah.
So yes, there are tools.
Exactly. Yeah. What I mean that
but the Online Safety Act is a newborn. Okay, so this is 2023, and it came into enforcement just recently.
Yeah. So what I meant is that it wasn't a criticism, but what I meant is that we are very lucky because we live in a country in which we have a lot of regulations about user privacy and security. What it's missing is like automated tools for enforcing, for regulators to enforce these regulations, and for the user to get protected by through these regulations. So at the moment, for example, just to give you an example, we have an IoT taskbed at UCL where we have hundreds of Internet of Things devices. 60% of these devices are not compliant with GDPR, and they are not compliant with PCTI or the Cyber-Resilience Act. That for the ones that don't know, it's new regulations, European regulations of cybersecurity for Internet of Things devices or any connected devices. So the main gap that I see nowadays is that we have a lot of regulations. We don't have tools for enforcement and for protecting the user through these regulations. So it's not just about making new laws, but it's about building new infrastructure supporting these laws.
A hurdle. We talked about hurdles earlier, right? So some of these platforms, well, not some, most of these platforms, they are international. Okay, so when you, I'll have to be careful what I'm going to say. So these are international players, and when you enforce fines on these international players, there are ripple effects. So as I said, it has to be proportionate, it has to be through the process. And again, I'm more than happy to connect you with the specialist colleagues within Ofcom to help you, and the DRCF as well.
So when you mentioned the kind of international setting to that, so how do we balance those concerns that our kind of public citizens may have around kind of privacy concerns with our overarching kind of national security needs as well? Because I imagine that's another kind of layer of complexity in terms from a regulatory and also from a kind of independent perspective from each government.
One comment I can make, I mean, that there is a balance, as you say. I mean, I guess just to be a bit more explicit about what I think you're asking is sort of how do law enforcement agencies get hold of data that they need while protecting the end user from unwanted access to their data. I mean, we have in 3GPP a group looking at lawful intercept, so what mechanisms can be put in place for lawful intercept of data. Obviously, that has to be very, very limited, very restricted. But at one end of the spectrum, you have the debate going on, for example, between Apple and the UK government right now. That if the government demands a level of access to data that companies are not willing to provide, you end up losing the whole service from the UK altogether. So it's that kind of balance and unforeseen consequences one ends up having to deal with. I don't think there's any easy answer. Debate is ongoing.
Yeah. So I think we should throw it open to see if we've got any questions in the audience. Oh, so we've got hands up on this side.
It's always the left-hand side.
They went instantly, so just catch off as you go up the stairs.
Yeah, so I was interested in what you were saying about the shared access license, because we've actually had to kind of use these for 5G content production for things like the Commonwealth Games and also the Coronation, where we kind of had obviously a shared access license in the N77 band which we can then use and deployed services in a particular location. And some of my colleagues have rumoured that there's potentially a automated access portal that might be under development. And whether this is wishful thinking on their part,
I can't comment on rumours.
But do you think that's something that would be potentially...
As I said, we have a process and we continually improve that process. I'm more than happy to take your question to colleagues internally, if that helps.
Okay, great.
Shouldn't have asked that.
So, Cameron, I'm going to go to the gent in the corner, then I'll come to you next.
Thank you. James Youngs, UK Ministry of Defence. In 2014, I was one of the authors of the UK government's spectrum strategy, where the #1 message was spectrum sharing was the future. Mobile doesn't like to share. When I moved to Ministry of Defence, we discussed dynamically sharing some spectrum with an MNO in the UK, and they weren't interested. It was only when I said it was sharing or no access at all that they showed any change to that attitude. We need spectrum access to defend our countries. The days of defence users jumping out of spectrum bands to enable faster download of fluffy cat videos are long gone. Does the panel believe that the MNOs will ever realistically be open to genuine sharing of spectrum?
Just to be clear, I can't talk on behalf of MNOs. I can talk on behalf of Ofcom.
Yes, sure. Matthew, anything?
I mean, I can't talk on behalf of MNAs either, but I think maybe a little bit in their defence. I mean, I think I would question whether MNOs are, whether it's fair to say that MNOs are not genuinely interested in sharing. I mean, I gave the example of 7.1 to 8.4 in the US. We also have the CBRS band in the US at 3.5 gigahertz. There are examples of sharing with incumbents, such as departments of defence. So I'd question a little bit the premise.
Cameron?
Yeah. So my question is around this trials which are being done on mice for acceptability of mobile comm. So ITIS from Switzerland is doing these trials since early 2000, and they published hundreds of reports. But the problem is still there, the acceptance of user and the trust. So I want your comment on, shouldn't we start thinking on using some new technologies like RIS, reconfigurable intelligent surfaces, to reduce uplink power, which will ultimately reduce SAR to make it more safer, instead of doing trials which are very limited in terms of time, because if we want to see a real impact, it needs to be at least 100 years, 200 years to see the real downside of technologies, because this time frame for trials is very short.
Okay, I think we cannot wait for 100 years, but there is one example which is quite often discussed in the general public, and that is if people use the mobile phone for decades, some people argue that there should be an increase in brain tumors, and in fact there are increases in brain tumors over the last decades, but that is due to the increasing age of the population. If you have a age-compensated analysis, this line is flat. And so that means all we can do is, unless we completely agree to throw all the mobile phones away, is to do what we can do with animals and with cells, and also to do epidemiological studies, that is looking for human health, whether there is any trend, especially with regard to brain tumors, and that is it. There's no theory saying that other effects, like except from heating, are responsible for potential biological effects. So from a biophysical point of view and from a biological point of view, everything has been done properly, there is always a possibility that after decades or after generations there may be effect. But this chance is so small, I don't believe that we will see any.
All right, Nicholas Serafinovsky with FTH. Thank you very much for the panel and the great discussion. There's lots of questions, but as I've bothered most of you individually, I'll focus on the biological effects. So one of the interesting things is, at least as far as I'm aware, EMC regulation, especially within the EU, typically focuses on maximum output power per, spectrum band per device. Have you looked at any of the consequences of compounded emissions? A very simple example, Wi-Fi access points will go through regulations at, 50 milliwatt output power on 2.4 gigahertz. But we don't have one access point. Typically, especially if you live in a multi-tenant building, you're being blasted by anywhere between 10 to 15 of these things. So I'm just curious about, how much you've looked at the compound effect of RF onto these mice studies or something similar to that.
Actually, there have been investigations performed by studies from the German Office of Radiation Protection to look for cumulatory effects of different sources. But the end result is that the thresholds, the legal thresholds of exposure are never crossed. So even if you are in a room which is equipped with all kinds of hotspots and many people use their phones and so on, the individual's levels are never exceeded.
Maybe worth, if I can just add to that, just by the laws of physics, the greatest protector against radiation from phones is distance. And this is one of the strongest arguments in favor, actually, of having base stations near to where you are.
Yes, exactly.
If you have a base station near to where you are, then your device will reduce its transmit power, and that will dramatically reduce what you're exposed to compared to what you might be exposed to from the base station.
That's actually an argument. When you say that in public, you are almost killed.
I think we have time for one.
Sounds like you speak from experience.
Yes. I think we have time for one last question.
Well, I'll have a question, then I just want to make a small point. But Matthew, you've given me the perfect segue. Thank you. My question is, and the answer to it might be a simple no, but I'm going to ask the question, is might there be a forthcoming challenge or problem with electromagnetic exposure from smartphones in connection with direct-to-device from satellites? Because to make the link, the smartphones will almost certainly have to be on maximum power all the time. That's my question. Do you want to have a go at that first, and I'll just have
what very simple answer.
And it wasn't necessarily to you, it was just because you segued into it. So
there are actually different output power limits depending on whether a device is a handheld device or not. So if you have a vehicle-mounted device, for example, it's allowed to transmit at higher power than a handheld device. That's the simple answer.
I was thinking of handheld devices, but yeah, point taken.
It's minus 23 dBm, isn't it?
It's a power class 3.
Okay.
And my sort of observation was around the conversation on spectrum sharing and interference. And I think the context of that was mainly in relation to terrestrial communications. But in the context of satellite communications, and given that that is an important part of the telecoms ecosystem going forwards, then spectrum sharing happens all the time. Interference, I'm suggesting, is a growing problem, and it needs looking at from a regulatory perspective, yes, but from a technological perspective, for sure. And I know for a fact that there are innovations going on in that, no pun intended, but in that space. Thanks.
So I will wrap up there. I'm sure there's conversation opportunities afterwards, but I just want to reiterate our thanks to all the panel members. Thank you very much for your time, and I'll pass back to Catherine.
Thank you.